problem. How many bit strings of length 12 contain at most 3 ones? So that's any bit string that has 3 ones. Right? Don't worry if that isn't exactly 12. It's supposed to be 12 length bit strings. Or 2 ones, or any, just 1, or any bit string with no ones, all zeros. Right? And so on and so forth. ... Right, and so I drew these in this random order because this one can also be over here, right? And there could be a 0 replacing it, right? And same thing goes with all these other things. Order does not matter. So we're gonna do, let's see, 12C, or really I should do this notation differently, but whatever, we'll just do it for now. 12C 3, right? Yeah, 12C3 plus 12C2 plus 12C1 plus 12C0, and this is just the same thing as, C12.3, C12.3, C12.2, C12.1, right? They're all the same thing, just different notations. And so this is just going to be 12 factorial over 9 factorial, 3 factorial, right? Plus 12 factorial over 10 factorial, 2 factorial, plus 12 factorial over 11 factorial, 1 factorial, plus 12 factorial over 12 factorial, 0 factorial. And so, just going to do a quick bit of calculation. I really should keep a calculator out. So that's 12 times, I'm doing the first term here, times 11 times 10 divided by 6 is 220. And so the way I did that is 12 times 11 times 10, and then the 9's canceled, right? 9, 8, 7, 6, 5, 4, 3, all those canceled too. And then so that left me with 12 times 11 times 10 over 3 times 2, so that's just whatever 12 times 11 times 10 is divided by 6, and that is 1320 over 6, which is 220. And then, yeah, it's going to do the same thing here. 12 times 11 divided by 2, 66. Okay. And then the same thing for the next one, 12 divided by 1, it's just 12, and then 1, right? 12 factorials cancel, you're left with 1 over 1. And so that's going to be, wait a minute, what was this one again? 220. So 220 plus 66 plus 12 plus 1 is 299. I don't think that's the right answer at all, but we don't know. Actually, how would I know whether that's the right answer? I've never seen the answer to this problem, so yeah, that's probably the right answer. Okay, let's do part C, at least 3 ones. This is going to be C of 12.3, right, at least 3 ones. So you're just going to add up all the combinations of C 12.3 plus all the combinations of C 12.4 plus all the combinations of C 12.5, right, all the way up to C 12.12. Okay, dot to C plus C 12. Off the page. Plus C 12. Yeah, so that's a fairly large sum. That's going to be really annoying. So let's just write out what, the bare minimum, what we have to, plus 9 factorial times 3 factorial, right? Yeah, and this is times 2. Plus c. Just go about doing it the normal way. But like, yeah, this is 12 factorial over 8 factorial 4 factorial plus, times 2. Yeah, there's no way this is all going to fit on my screen. Okay, let's just see what we can do, because you guys have to calculate this out too. You're probably going to skip like 5 minutes ahead if you've already calculated this. So yeah, 12 factorial over 9 factorial. 3 factorial plus 12 factorial over 10. Oh, that's not even right. It's 8. It looks like 80. I really should just figure out how to use the eraser. Really? I thought it was right here. Aha. Okay, I think I got it. Did I get it? I guess. Okay. So anyway, let's go. What is the next one? 4. C 12 4. So 8. What? 8 factorial 4 factorial plus 12 factorial over 7 factorial 3 factorial 5 factorial. And okay, I think we start computing some of these. We'll just kind of remember the format here. 12 times 11 times 10 divided by 6, 220. And we're going to multiply that by 2. We're actually going to get a second one of these later. You'll see. And then 12 factorial over 4 factorial, or, 10 times 9 divided by 4 factorial is 16. So it would be 11,880 over 24, which is 495. We're going to multiply this by 2 as well. Because this is for 3. This is for P of, what is it? 12.3. But it's also, or sorry, C of 12.3. But it's also C of 12.9. Because both those come out to 12 factorial over 9 factorial 3 factorial. Okay? They come out to the same thing. And then my goodness, excuse me. I'm getting over a cold. 12 times 11 times 10 times 9 times 8. Whew, this is starting to get yeah, so 792 times 2. Wow. Okay. Plus, let's do a plus down here. I'll start it there. For 6 and 6, right? With P or of C 12.6. We're going to compute C of 12.6. 12 times 11 times 10 times 9 times 8 times 7 divided by 720 is 924. And I think, does that even cover it? No. We still have to do, we still haven't done 12 factorial, 10 factorial, 2 factorial. We haven't done 12 factorial, 11 factorial, 1 factorial. Oh my god, this problem's so long. And the last one, which I don't have enough space for. Yeah, so that's just 12. We'll do the first one. Do this one here. We'll do 12 times 11 divided by 2. 66 plus, what's the next one? 12 plus 1. Okay. Okay, what do these add up to? 220 times 2 plus 495 times 2 plus 792 times 2 plus 924 plus 66 plus 12 plus 1 is 5,502. Okay. Oh, are we done? We're not even done. Okay. Wait a minute. there's another one. An equal number of zeros and ones. Okay, so that's just, thank goodness this is a short one. C of 12.6, which is, what was C of 12.6 again? 12 times 11 times 10 times 9 times 8 times 7 divided by 6 times 5 times 4 times 3 times 2 times 1. Sorry. Divided by the quantity, 6 times 5 times 4 times 3 times 2 times 1, which is 924. And that's the end of number 12.